All right, in this example, it says that the probability that a SIM card produced by a certain company is defective is 0.02, so 2%. If a sample of 10 cards is selected at random, what is the probability that it contains no defective cards or at most 2 defective cards? All right, so first of all, this is probably a Bernoulli experiment or a binomial experiment, right? Because that's what we're studying right now. But we can check, right? Because do we have 2 possible outcomes? Yeah, we have a fixed number of trials because we're selecting 10 cards, so our n is equal to 10. We have 2 possible outcomes. It's either going to be defective or not defective, and the probability that it's defective is 0. Oops, hang on. Is 0.02, which means the probability of not being defective is 0.98. Okay, so it seems to check out that this is a Bernoulli experiment, or binomial experiment, I should say. Now, so we're first of all asked to find the probability that we don't get any defective cards. So we're going to define our random variable to be the number of defective cards. We're going to call defective cards a success, okay, because that's what we're looking for. So I wanted the probability that x is equal to 0. No defective cards. All right, so we're just going to use a formula. We're going to take 10 choose 0 times 0.02, which is the probability of success, to the 0 power, and 0.98 to the 10th power. Okay. Now anything choose 0 is 0, and also anything to the 0 power, anything choose 0 is 1, and anything to the 0 power is also 1. So all we really need to do is take 0.98 to the 10th power, and I get 0.8171. So there's about an 81.7% chance of getting no defective cards in a sample of 10. All right, so we also want to know what's the probability that you get at most 2 defective cards. Now, what does that mean? At most 2 defective cards. So that means we're looking for the cases where either x is equal to 2 or less than 2. So or 1 or 0. Now, oftentimes with these types where it says at most or at least, it's good to look at the complement just to see if it might be easier to count, because we don't want to have to do more work than we already have to do. This chapter 8, there's a lot of number crunching, so let's look at what the complement of that is just to check it out. So that would be not x equals 3, or 4 or 5, or okay, it looks like that's a lot, out to 10. Okay, so it looks like it's easier to count this directly and just calculate the number of ways to get exactly 2 defective cards, exactly 1 defective card, or exactly 0 defective cards, which we already have that probability in part A. So really all we need to do is calculate the probability of exactly 1 defective card, or say and the probability of exactly 2 defective cards, and then we'll add in the probability of exactly 0 defective cards as well. Okay, so I'm going to just use my formula. 10 choose 1 times 0.2 to the 1, 0.02, hang on, 0.02, be careful, 0.98 to the 9th power. And that gives me what? 0.1667. All right, I can calculate the probability of exactly 2 defective cards, 0.02 squared. So my x is equal to 2. And then p is 0.02, q is 0.98. So there's the numbers plugged into the formula, and I get 0.0153. Okay, so the probability that we have at most 2 defective cards, which means x is less than or equal to 2, is just going to be the sum of all of these, including the case where x is equal to 0. So I'm going to add in 0.8171, so that's exactly 0. The probability of exactly 1 is 0.1667, and then we're going to add the probability of exactly 2, which is 0.0153. Add that all up, and I get 0.9991. Okay, so the probability of getting at most 2 defective cards is over 99%. All right, so there's another example here. One more. I think that's the last one. A lot of examples here. Take a look at it, see what you think about it, and I'll meet you in the next video.